Hello and welcome to this NextGEOSS webinar series. Today we have a webinar about clouds and Cloud API on the NextGEOSS platform, Data Hub and Platform. My name is Bente Liljaby. I'm going to be your host today. And with me, I have two experts on clouds, different type of expertise, and you will get to know them. But before we start with that, I will do my normal drill on these webinars. We will do a weather report. So, now I will ask you, Hervé, how is the weather and where are you?
I'm in Paris, and the weather is cloudy but shiny. A good light, going through the clouds. Yeah,
going through the clouds. Oh, fantastic. And you will get to know more about Hervé shortly. But before that, Björn, what's the weather like and where are you?
Thanks, Bente. I'm in Amsterdam and the weather is cloudy with a chance of infrastructure as a service.
Yes, how appropriate. This is fantastic. So, and you will learn more about Björn also shortly. I will give my weather report. You can see it actually here. This is proof of weather. It's cloudy here and the clouds are filled with lovely snow. We are in Norway, just outside Oslo, and you might know that Norwegian loves to go skiing. So with that, first some housekeeping, and then you will get to learn more about Björn and Hervé. We would love for you to ask questions, and you can do that in the chat box. So we can start by you giving us a weather report from where you are. Tell a little bit about the place and the weather. That would be lovely warm up of the chat box. And then you can ask questions and we will answer them, some in between the presentations. We have 3 presentations today. And then we have a Q&A at the end. So this webinar will be recorded and you will also get the PDF of the presentations. Am I right? Hervé and Björn, you can confirm this, right?
yes, sure.
Yes. So you know that now, but don't be shy, ask questions. So we will start on the program by first introducing our speakers. So Hervé Comont from Terradue, can you introduce yourself, tell people a little bit about yourself and what you do?
Yeah, maybe you want to hear my name with a French accent. So
yes, please.
So Hervé Comont, and I work for Terradue, an Italian company based in Rome, and I'm a platform operations manager.
And Björn Bakkeberg, with a very, very Nordic Scandinavian name, but you are not from that part of the world, are you?
No, I'm not indeed. I'm from South Africa originally, and recently moved to Europe. I work as a user community support officer at the EGI Foundation, and my job is to support scientists and researchers to make optimal use of the cloud infrastructures that they would like to use for their applications.
Fantastic. So I think we are ready to start to learn more about cloud APIs on NextGEOSS. Hervé, you can take it away.
All right, so I will share my screen, cut the video, and share screen.
Yes, and we will turn off our videos as well, but we will come back to you.
Okay, and that's the demo effect. Now I have some slowness in sharing my screen.
Ah, okay. Yeah, so this is something we...
Trying again.
Right. But in case you are not succeeding, I think that Björn also has the same presentation, or do you just have your own, Björn?
No, it's the same actually. So if I don't turn screen sharing on, I cannot. No, it's bugged. So that's really the demo effect. So many times have we tested it.
Yes.
And yeah, let me try again this way. No.
Yeah. Let's see.
No, the button is inactive.
Oh, really?
Yeah.
Okay, Björn, can you save us here and share the presentation? And then Hervé will give you commands. on when to move on.
Thank you, Bjorn. Yeah, we see the screen, the slides.
Perfect.
Perfect. Okay, so yes, today the webinar is about cloud APIs. I will present a short introduction. If you go to the agenda, we have 10 minutes of a quick introduction about the use of cloud APIs within NextGEOSS. And then Bjorn will take the floor to tell the story of the EGI Federated Cloud evolutions to harmonized APIs. And finally, I will be back to present the NextGEOSS Cloud Bursting Service. So that's a support service from Terradue, my company, for application builders to run on multi-cloud, run their applications and deploy on multi-clouds. Okay, so the first part, a quick introduction about the approach we have in NextGEOSS and how and why NextGEOSS relies heavily on APIs and especially cloud APIs. So next slide. So the pitch when talking about modern APIs is always something like, hey, see how fast we can go in integrating useful resources so to serve our user needs. And by the way, the European Copernicus program has invested so much in data generation and cloud compute capacities that the available resources are quite massive. So looking at the examples provided here below on the slide, all the Sentinel's satellite missions, all the information products derived from it, the European Open Science Cloud, the EOSC, the Data and Information Access Services, the DIaaS, this is huge. So this is available. So for the NextGEOSS team, the mission statement is quite simple. Let's master all the related access points in a programmatic way via application programming interfaces. So on the user side, on the user side, when you talk with software developers, when you talk with researchers or project directors, they work on a daily basis with so many actors or so many other professionals. Therefore, if you really want to understand their needs and deliver solutions to them, you have to incorporate in some way these work relations in your design. And there are so many different actors like software developers, scientists, decision makers, NGOs, and with so many ideas about useful collaborations and applications, you want to be able to onboard them, quite all of them, if possible. So for this, the natural fit is to go platform, being a platform. I mean here a collaborative workplace, acting as a matchmaker, allowing partners to take benefits of so-called network effects on a multi-sided marketplace, gathering many types of producers and many types of consumers, and deliver to them a set of platform services. So in a nutshell, platform services encapsulate the technology needed to take advantage of the data APIs and the cloud APIs available out there. And actually, let's have a closer look at these APIs on the bottom left of the slide. They are of two types. Some APIs are focused on data interoperability, typically implementing the Open Geospatial Consortium standards. And this is done by many data providers distributed all over the world. And some other APIs are focused on cloud computing resource provisioning, storage, compute, networking. And this is done by cloud providers such as Amazon Cloud, Google Cloud, as well as our partner in NextGEOSS, the EGI Federated Cloud. So the trend is even getting more acute when market players such as Google, Amazon, or in Europe, the Copernicus DIaaS, are actually providers of both types of resources, data and compute, and provide the related APIs. So overall, this is what the NextGEOSS team does with the NextGEOSS Data Hub and platform. Onboarding users for who the NextGEOSS team can deliver access to resources as well as dedicated support. Onboarding application builders in particular, as shown on the right side of the slide, as this is paramount for the platform take-up. So we call them pilots, and we have plenty of them already and growing. And such pilots are led by key stakeholders in domains such as energy, biodiversity, agriculture, and etc. And these stakeholders usually operate on their own portals in order to engage with their community of practice and deliver their products. Now, as a general rule for NextGEOSS, these pilots are selected accordingly to their capacity to help institutions, governments, and commercial sector organizations on implementing the United Nations Sustainable Development Goals, the SDGs. They are selected as pilots for their ideas to use Earth observations to achieve these goals. By the way, the use of EO data to serve the SDGs is coordinated worldwide by the Group on Earth Observations, GEO, which regroups over 100 member states of the United Nations, plus the European Commission, plus over 130 participating organizations, for example, international standards organizations. And also since this year, a new membership status, GEO Associates, more oriented towards firms and the civil society that my company Terradue has already joined. So overall, the NextGEOSS team is developing platform services that automate the access to APIs and their resources so that a greater number of community portals are empowered to run scalable Earth observation data processing tasks on the cloud. And we have a very nice collection of NextGEOSS platform services, the many green boxes encapsulated by a blue highlight on the slide, and all equipped with programmatic APIs and used by application providers, application builders to empower their community portals. So as you see, really it is API everywhere. And today we will focus on presenting the cloud APIs that are used to provision compute and storage resources on the cloud and to deploy and run user applications in production on these cloud resources. Also, as these platform services are meant to be delivered on a self-service mode, we are putting efforts on the documentation as well as on the bundling of the NextGEOSS offer that clearly advertise each capability. So let's go through quickly through these offers, bundled offers. So we have, for example, this is the Cloud Integration Service Bundle for the users of this type of APIs to make data processing algorithms scalable and portable across cloud providers. So people access cloud sandboxes, which are equipped with a standard SDK and connecting to APIs to stage data, run jobs, and package applications. We have also the User Management API. So this is the User Management Service Bundle. And here it allows application builders to get authenticated, get their application user authenticated via single sign-on, and to control how their users, typically on the community portals we have discussed, how the users are authorized to consume cloud resources when they run processing jobs. Another example is the Data Discovery Service Bundle, part of the NextGEOSS Data Hub. And for the users of this collection of APIs, the service provides standard API to fetch and consume data resources within applications. We also have the Geospatial User Feedback Service Bundle, where you get guidance to install a widget on your community portal that will interact with the server API to deliver and manage user feedback. So it will allow you to build a knowledge base on the server where you can collect all the user information related to the quality and the relevance of the data that you deliver typically. And finally, the cloud bursting service bundle. And for the users of this collection of APIs, we provide a cloud controller APIs to ensure that cloud provisioning is performed according to the credit lines that are in place. So people need to have a contractual or a sponsored access to cloud computing resources, of course. And then getting access to so-called deployer APIs, where a user will define a configuration and deploy a packaged application on selected cloud. So back to our platform idea, and to conclude, the goal of today's webinar is to focus on the cloud APIs within NextGEOSS. The EGI Federated Cloud is a NextGEOSS partner providing cloud computing resources to the application builders. And there is an EGI story about past improvements of their services and APIs. So I leave the floor to Björn Backberg for him to show what was happening behind the scene. And after that, we'll come back to how application builders in NextGEOSS can manage their applications on the cloud in flexible ways, thanks to cloud bursting APIs.
Thank you, Hervé. It really shows how important APIs are in making our system interoperable, and in fact, making system of systems a reality. So if you have any questions concerning APIs in general, you can please ask in the chat box, and we will answer the question now. Björn is ready, so we will answer the questions after Björn, or at the end in the Q&A. So Björn, you are ready to dive deeper into the EGI API, right?
Yes, thanks, Bente, and thanks, Hervé. Can everybody hear me okay, I hope? So I'm going to talk a little bit about the EGI Federated Cloud and the APIs that we use to have a unified user experience in the distributed cloud infrastructure that is the EGI Federation. But before we start, I thought it would be useful to describe what the EGI Federated Cloud is and what it offers. So essentially, the EGI Fed Cloud, as we like to call it, is a distributed multi-cloud infrastructure as a service, or IaaS, that gives users the ability to run virtual machines on demand. And this is quite similar to what Amazon Web Services or Google Cloud Platform does. And what we've done is we've provide a harmonized access to the various cloud sites that contributes to the resources of the EGI Fed Cloud. And these infrastructures are both academic or public infrastructures as well as commercial infrastructures. And essentially, they enable us to provide services such as cloud compute, cloud container compute, the storage requirements that go with those, as well as applications on demand and the Jupyter notebooks that are becoming very popular in terms of analyzing data. And we are also able to provide training infrastructures for hackathons or those kind of things. Some of the key features of the Fed Cloud is that the Fed Cloud is essentially technology agnostic. We support a range of different infrastructure deployments based on OpenStack or OpenNebula and Cinefo. And essentially what we've built on top of those things are things like single sign-on, a virtual appliance catalog with a unified graphical user interface, which allows you to deploy your VMs. And there are also tools for resource discovery and customer relationship management. And I'll talk a little bit about that in the next few slides. So originally, the EGI Fed Cloud was launched in 2014 as an abstract cloud management stack subsystem, which we call the Cloud Infrastructure Platform, or CLIP. And this was integrated with components of our core information management system. Essentially what CLIP is, it's a thin layer of federation and interoperability services that are around the local deployments of the cloud providers, allowing these distributed providers to be part of the distributed or federated infrastructure as a service. So to enable collaboration between these distributed infrastructures, EGI originally mandated that each provider makes at least one interaction port or API available to interact with the infrastructure. And at the time, when we first launched this federated cloud, we pushed providers to use what we called the Open Grid Forum OCCI API, which was at the time the only independent community-driven standard. But then over the years, we realized that it was quite difficult to impose OCCI as the single interaction port for the providers and the users. And in fact, OCCI lacked support in terms of the user tools and feature lists that it provided, which resulted in us as EGI having to interact manually to manage and provide the virtual machines on the infrastructure as a service. And this essentially gave us limited opportunity to adopt cloud native approaches where resources are managed in an automated way via API calls. So we then decided to allow all of the providers that are part of the federation to decide for themselves which API standard they would want to implement. And we shifted our focus towards building the tools to enhance the user experience by building common interfaces to allow the user experience to be unified, essentially. This also allowed us to automate the resource provisioning, which I'll show you a little bit later. So as it stands, the current access layer can be illustrated by this figure here. As I mentioned, we moved away from the OCCI API, and we no longer mandate a single API for every provider. Instead, each provider have their own APIs, and we basically ensure that these can be used with our federated authorization and authentication infrastructure, which we call EGI check-in. And while OCCI is still widely supported, most of the sites have now moved towards cloud-native APIs such as OpenStack. And this approach opens the doors for automation of cloud-native applications, and these federated access tools that we built help users to deal with the heterogeneity of the infrastructure that is part of the EGI Federation. So users and developers can access the EGI Fed Cloud at different layers, either using a GUI, a graphical user interface, which is at the top layer there, or they can use their preferred orchestration tools such as Infrastructure Manager or Terraform, or they can directly access the infrastructure as a service using the APIs. Essentially, the APIs that we support enable the Fed Cloud features, including monitoring, accounting. There's a configuration database, which is basically keeps all the information about the various images that you can deploy. It enables information discovery, as well as a application marketplace. So here you see the typical user flow when interacting with the EGI Fed Cloud. On the right-hand side, there you can see an illustration of the heterogeneous infrastructure as a service clouds, which are based on largely OpenStack, OpenNebula, and Cenefa are also supported. And then what we do typically is we group resources into pools, which we call virtual organizations. And then users can discover these resources, and as well as the virtual appliances in what we call an appliances marketplace, where users interact via a REST API or via a portal that we maintain. The AppDB or cloud marketplace basically returns the necessary information about the cloud endpoints and provides the virtual machine templates that the user can then deploy in the Fed Cloud, either through his own tools, such as Terraform, or less advanced users or less savvy users can use a portal that we've developed, which has a wizard-like dashboard to deploy the resources in the Fed Cloud.
Bjorn?
Yeah?
Can you go back and forth on the slides, because they are currently frozen on the current access layers?
Oh dear. Can you see the slide that says typical user workflow?
Not yet. Yeah, okay. This is back.
Okay, great. So So let me try that again.
Let's have it in the presentation. Yeah, there it comes. Okay, fine. Go ahead, Björn.
Yeah. Okay. Okay. So this slide illustrates the typical user workflow when you interact with the EGI Fed Cloud. So on the right-hand side here, you see basically the different cloud infrastructures grouped into what we call virtual organizations. So what we do is we basically take the resources that are available and put them into a resource pool, which we call these virtual organizations. And then these could be either projects. In OpenStack, this is called a project, but we call them virtual organizations. And then we allocate those resources to users. In the Fed Cloud, these resources can be based on OpenStack, OpenNebula, or Synéfo. And then the users can discover the virtual appliances that you can deploy in the cloud at our applications marketplace. And this can be discovered via a REST API or via a portal that we maintain. And then the applications database, this AppDB, then the API built that the AppDB API returns the necessary information of the cloud endpoints and provides virtual machine templates that the users can then deploy in the Fed Cloud. And the user can do this either through his preferred tools, such as Terraform, or less advanced users may do this through a portal where we built a wizard-like dashboard that allows users to deploy resources in like a point-and-click kind of fashion. So I'm moving to the next slide. I hope you can see it.
Yes.
So expanding a little bit more on the portal, the application database, or AppDB, is essentially a registry of validated virtual appliances for which there's a recipe that allows you to deploy the virtual appliances in the Fed Cloud. So virtual appliances are essentially logical containers or versioned image files and metadata bundles. It's basically an operating system image that you can launch into the cloud. This will give you an operating system such as Ubuntu or CentOS or other operating systems of your preference, including the software applications on top of them to use in the cloud. So all of the infrastructure as a service providers, part of the EGI Fed Cloud, provide lists of virtual applications that can be used on their infrastructures for a given resource pool. And at the bottom here is the base API that allows you to, the RESTful API that allows you to engage. So built on top of these APIs is a dashboard which we call VMOps. VMOps is a point-and-click solution that allows you to create and manage virtual machines in the cloud. It basically gives you a wizard-like user experience, so you can point and click through the various steps to get a virtual machine up and running in the cloud. This basically takes away the complexity of doing all of the back-end work. In this case, our VMOps dashboard is powered by something called Infrastructure Manager, and it is also integrated with the other EGI Federation services such as single sign-on, the discovery tools that we maintain, a virtual machine catalog, and including monitoring and accounting and a whole range of other services that are provided. And the integration is, this integration of services is essentially facilitated through a range of APIs. And here at the bottom, you see a list of the various APIs that we use. And of course, if there's more information required, we can always provide it upon request. And typically, these information are stored publicly. So today, the EGI Fed Cloud consists of 23 distributed infrastructure as a service providers distributed largely throughout Europe, but we are consistently expanding this, the providers, and at the moment we're even working with the South African cloud infrastructure to integrate their infrastructure into the EGI Fed Cloud. And the activities of this distributed infrastructure are coordinated by what we call the EGI Cloud Task Force. And over the years, we sort of on average provide about 2,500 compute hours that are consumed every year, and almost 600,000 virtual machines were deployed by users or for users from a broad range of scientific disciplines, with a large portion of the users coming from natural sciences, including NextGEOSS. The figure in the middle at the bottom there shows you a high-level architecture of the EGI Fed Cloud, where users can essentially, let me do this, I don't know if that's going to work, where users can access the various layers of the Fed Cloud via the single sign-on. This is essentially the layer where all of the providers sit, and then EGI provides these federation services that allows the providers to work together, as well as the orchestration tools needed to deploy virtual machines. And the research communities can build their platforms on top of this in a unified way. And here you see NextGEOSS is one of the user communities that we support, and as well as a range of others. So in the future, we plan to expand our capabilities and the capacities of the federated cloud. In particular, there is an increasing need for GPUs, high memory and compute intensive VMs, particularly with this move towards artificial intelligence applications. Another thing that we're working on quite strongly is to improve the discovery of resources and tools. And we're moving towards an API-based management of resources, where EGI essentially removes itself from providing the resources and enabling the users to do so on their own via a range of tools. At this point, then EGI only becomes involved with the service level agreement setup, making sure that the users who are using our resources are supported according to what is agreed in terms of service level targets. What we really would like to have is to also support our providers by simplifying the integration, so that the provider doesn't have to worry about maintaining a connection to our applications database, that activity is centralized and that we maintain that activity. And then we are continuing we are also liaising with commercial providers, in particular the Copernicus DSs, to ensure that the researchers can, in the future, easily move from a sort of pilot application to a more operational application with some commercial benefits, without the need to report everything to a different cloud infrastructure. And with that, I would like to give the floor back to Hervé, who will describe how users can manage their cloud applications in a flexible way using the Cloud Bursting API.
Thank you, Bjorn.
And while Hervé is getting ready, I just want you to notice I asked a question to the audience, whether or not they have used cloud technology. And most of the attendees here have used it, but there are also some that hasn't. So we can come back to that. I can ask some questions. If you are not asking yourself in the chat box, I will ask some questions concerning that for the newbies on cloud technology. But before that, you can go ahead, Hervé, and continue your presentation.
Perfect. All right. So yes, the NextGEOSS Cloud Bursting Service is one of these platform services I have introduced earlier, and this is the one which directly connects and leverages the EGI infrastructure as a service that Bjorn was presenting, and so relying on the APIs for automation, so that we release the burden on the users, on the application developers typically, to get into that details, and this is abstracted for them, and this is delivered as a service. So cloud bursting, some use cases, there are many different reasons why some application developer or some project director might be interested in this capacity. In a nutshell, it is about capitalizing on a development, on a software development, an application where you have in place all the data interoperability and all the scalability layers in your application, and you don't want to change this as you move from one cloud to the other for your production needs. So there are two times. There is the integration, development and integration time. And then you want to leverage this effort for the production time, where you need to consume some storage, some compute, and deliver products on a different basis. So, for example, you might need multiple deployment of the same application for different target user audiences, because, for example, they live in different regions of the world, and you want to improve the delivery, the time to delivery to these audiences by region. Or you need to perform different production campaigns that require to secure dedicated cloud resources over a given period of time. Another kind of use case is that you need to perform multiple deployments of different versions of the same application, simply because you will control the audiences of these different versions, for example, according to different funding contexts. So a stakeholder is funding a new evolution of the application, and you want to deploy it for the intended audience of this stakeholder. So let's have a look at some prerequisites as we approach the domain in NextGEOSS. In order to being ready for cloud bursting an application over its lifecycle evolutions and over its deployment needs for its lifetime. So the rationale is to equip application builders with a so-called continuous integration environment, from where developers can use libraries, software development kits, which are in charge to take the burden of discussing with all these APIs and the cloud APIs that we have already viewed today. So there is an integration environment, that's the left part of the pipeline, of the continuous integration pipeline, where people can access a virtual machine, a developer cloud sandbox, to test and integrate and validate their data processing components. Then they will go through a build and packaging process that will prepare the software for its distribution on target production environments. And here, this is where we encapsulate all the SDK and the software library calls to APIs that are needed for the application, like data fetching, querying a catalog, getting the list of products that will be processed, and so on. And also the wrappers that will ensure scalability. There are different solutions nowadays for scalability. Here we are, for NextGEOSS, focusing on Hadoop, which is a well-known framework to perform massive distributed parallel processing. And in the future, we are studying today Kubernetes. There will be additional frameworks supported. And then the final step is the cloud bursting, leveraging a deployer engine, and which will take the application package and burst it towards a production environment that is already provisioned. This is automated via the platform APIs for the user on a selected cloud. We support many cloud providers, and so let's have a look today on the next slide on the current state of affairs with this multi-cloud provider support. So on the NextGEOSS platform service for cloud bursting, this service is powered, still waiting for the slide. This service is powered by an engine on Terradue Cloud Platform. Yes. Yeah, you can move on the presentation mode. Yeah. It's getting slower and slower. Yeah, fine. That's fine. Thank you. And yeah, the engine for NextGEOSS is provided by ELIP. ELIP is the engine of the NextGEOSS Cloud Platform for the cloud integration and the cloud bursting services. It is hosted and operated by Terradue, and also supports other flagship initiatives such as the GEOSS exploitation platform that Björn was quickly presenting at the end of his presentation, or the integrated Arctic observing system. So we take in charge with ELIP on Terradue Cloud Platform the connectivity to this multi-cloud provider world, so that we can abstract this for our partners who can focus on their data processing workflows. So back to our use cases, we have in the past year performed several improvements to the cloud bursting service, soon to be released in a new version. The code name on ELIP is ELIP launchpads, and it is a way for users to get a simple dashboard where they will perform what previously Terradue did on behalf, which was to select an application package and to select a target production cloud. So it will look like a dashboard, a simple dashboard, where people are empowered to deploy and operate the resources in support of some application provider needs. We're still waiting for the slide refresh.
Oh dear.
Yes. And so after a setup phase and after the validation of a cloud appliance on the integration environment, we are supporting a workflow for the authorized and selected cloud production environments per pilot to be reached. So you need to have some account on the cloud provider that is configured for you, and you need to have some credits. And NextGEOSS typically will provide this. This is what NextGEOSS already provides as a bundle for the pilot users. So I have a few slides after that to show the typical user operations, the user task to perform cloud bursting. So the first step, people will browse a repository of available, typically the cloud appliances they have built, which are ready for them. So they will select a URL typically to a Git repository of their application. That's the reference to the cloud appliance to be deployed. And then they will, next slide, they will define the deployer services to be invoked. So these are resources provided by the platform to them. So they will have a list of supported providers on which they can deploy. So here for this example, the user wants to deploy a same application on 2 different clouds. And finally, on the next slide, we just ensure that so yes, that's the more detailed example of the different providers that are selected. And we can go to the previous slide where the user will submit the burst operation, and the platform will make this application build and package and deploy operation on the selected provider. After that, you will have monitoring tools. I've been very quickly on this on the introduction. And yes, that's a summary slide on the effort we have performed in NextGEOSS to evolve and support users of this service. There is an integration guide, there are online documentations, there are support activities that are available to all the pilots. So we are still accepting some new pilots in NextGEOSS, and the list of pilots currently in operations and the upcoming ones. So the offer, again, as a wrap-up, the 2 last slides, the offer is about making your cloud-ready application available as a cloud appliance on the platform repository. Then you decide on your cloud appliance access conditions, only for your own organization or shared with other partner organizations. So here we are rejoining the dots about being a platform and supporting collaboration between different type of users on the platform and different organizations. Then leverage the deployers which are previously set up for you according to your existing cloud provisioning arrangements. So you can come to us having an account and having arrangements to consume cloud resources on a given cloud providers. We will enable this on your platform account and adapt your cloud deployment strategies as a result. You now get a way to, from the resources that you can access on the platform, decide where and how to deploy for production. And the last slide is a simple example of what partners have done. So here, this is the case of the Armin partner in NextGEOSS. They are specialists in solar energy systems, helping organizations to, for example, install solar plants and optimize the installation of solar plants. And they study sunny conditions on different landscapes, and they provide this kind of assessment as a service to their partners. And currently they have two applications. One is based on the OGC web processing service interface for the managing of processing jobs. So they run and monitor data processing jobs and deliver the output results. And another one is more interactive and is planned to be open to a range of early adopters, which is accessing the same endpoint on the cloud, but from a Jupyter notebook. So that service will be authorized thanks to the NextGEOSS Platform Services to a range of users that will be authorized to consume cloud resources for getting products over their areas of interest. So Bente, this is it for the three parts of today's webinar.
Ah, fantastic. Very interesting. Thank you so much. Can you unshare your screen then, Björn, for us? And we can come back to you so you see who we are again. We can immediately take one question. We have a very simple question from Timothy, asking if there are no support for Ali Cloud.
So that's the Alibaba, but not yet, not yet. I hope this will come. Probably, I'm wondering actually, since a few months or maybe a year, what will drive this kind of support? Probably partners from Asia, and this is not yet the case. So, yeah, that's a big one for sure. So for us, the market is not for NextGEOSS and for Terradue, the market is not yet there. We see in some other projects some interest from Asia, a lot of users. So it could be the case that soon we have support for Alibaba Cloud.
Yes. So yeah, one thing is the data, and the other is what you process and where your data are placed. There's a whole lot of APIs here, and you mentioned some standards, but in general, so for NextGEOSS in this case, are the APIs that you offer for the cloud here based on open standard, or is it other versions as well?
Yeah.
So from an EGI point of view, we very much support open standards. Everything that we do is based on open and open source softwares. We typically do not engage in proprietary type cloud work. I would like to also maybe comment on the Ali Cloud, although I'm not particularly aware of that cloud in particular. Just to say that there are discussions happening to develop a so-called global cloud, essentially, where we are engaging with partners from Africa and China to federate the resources into a global system.
Right.
Yeah, and so the cloud APIs, cloud computing APIs have gone through a maturing process, and there was quite a competition in the past years. And obviously, Amazon Web Services APIs can be considered proprietary, but some of these APIs have become de facto standard interfaces, de facto standard like S3. So yeah, the market is stabilizing. We can more and more rely on past developments, so this is good, more stable. But anyway, there are technological evolutions, there are new developments, new frameworks. Kubernetes is one of them, and so for us, it means we will always have some kind of mission to augment Terradue cloud platform interfaces to support more users or to support more demands for a given cloud that would be of interest.
Absolutely. So, so a global hyperscaler, Timothy is commenting, but I believe you already commented back on that, Björn, or do you want to expand?
No, but I would like to second Timothy's comment that is a really good idea.
Yeah. Yes. So my understand. Well, first of all, I did another poll here asking the attendees whether or not they were planning on using cloud APIs, and some of you were not sure. So maybe if you can tell us in the chat what questions you need to have answered before it will be easier for you to decide on it. We can then have some ideas, maybe help you in your decision process. While you are writing that, I have a question concerning the deployment of your processing algorithms. Can you, from the NextGEOSS platform, can you deploy on absolutely, well, those clouds you have described? Can you deploy, like you can deploy it one place and then I want to deploy it on another? Can you easily switch between the different clouds that are using for your processing?
Well, what we see is really that partner organizations need to establish a strategy. So what we do is to support them in this kind of strategy. So they have budgets, they have delivery campaigns to be ensured. And later on, we can discuss the case of the partner Vito, for example, and how they approached NextGEOSS and how they are using NextGEOSS in their corporate and business operations. So it's not like you go back and forth. It's more like you have a strategy because of different budgets, different regions of the world, and eventually different capacities of cloud providers that you want to exploit. And the question is how to establish a solid strategy and be able to enact this strategy in a work plan. So we support partners in doing so. And so we support them to plan different production campaigns. And it doesn't have to be always on the same cloud. And it doesn't have to be subject to any vendor lock-in with a given cloud. So that's more about this kind of strategies. Then Vito, for example, they have customers on the agriculture domain, and they have in-house capacities, and so they have well-known and well-planned production requirements. But from time to time, they can have business development activities, or they can have unexpected demands, and they like to use NextGEOSS to absorb the load in this kind of situations, and use the single and same application packaging they have done to support this kind of new loads. So this is how we serve, typically we serve customers and partners.
Right. So in general, you have a strategy on which cloud service you want to use beforehand when you build your application or service. But as we were discussing, there might be other providers and the price might change and so on. And my understanding is that when you build something on the NextGEOSS platform, it's fairly easy for you. Like you don't have to do a whole lot of coding and etc. to burst your application to another cloud. Say if the conditions are changing, for instance.
Yeah. So as Björn was discussing, Terradue and EGI, we are partners for many years now. So we have absorbed the heavy load of the backend work to connect all these mechanics of building an application and being able to deploy it on virtual machines, which give you and your application the storage, the compute, the CPU, everything that you need, and the network, everything that you need. So all this can be heavy to handle for a newcomer. It's a specialist work, so we have done this. And then we deliver as a service. And the service is the capacity to deploy an application package, and it was mentioned in the webinar, but quickly, what you put inside this package, they are all the interoperability layers that you need, because you are tapping into distributed resources. As a comment after the first part, Bente, you mentioned supporting partners to work and operate in a system of systems, and that means that your application package encapsulates all these interoperability standards. And in NextGEOSS especially, we rely on open standards because we work a lot with scientific partners. We come from the research world, and this is a requirement. So this is in our DNA to allow partners to capitalize on open standards for the data access, for the catalog queries, for the retrieval and the fetching of data files, etc. So, and for the processing jobs as well, invoking a processing task and retrieving the results of all this is based on open standards. And so as soon as you have implemented this using our SDKs, it's there for quite long, because these standards tend to be quite stable on the provider's side.
Right, so your investment there will pay off. I will quickly go to Timothy again. Thank you, Timothy, for asking questions. So would EGI package the cloud bursting applications, or is it open to all to contribute?
The packaging, I'm sorry, I will answer for you, Björn, but the packaging is part of the Terradue Cloud Platform activities, and we have learned to do this again in a way that we are able to deploy a package on any cloud, whereas in some cases, if you start from scratch on Amazon and you rely too heavily on the Amazon platform, as an example, services, you will have to modify your code if you want to run this on a IaaS, and vice versa. So I cannot speak for each provider. So of course you can package an application on EGI, and Björn will explain in a nutshell how it works. But in NextGEOSS, the idea is to have an abstraction on top of this cloud native level, and work on a cloud agnostic approach.
Yeah, I guess that's essentially what EGI is trying to achieve, is this cloud agnostic approach as well, where the user experience is unified across the various providers that contribute to the EGI Federation. And as such, it's also quite important for us to collaborate and work with the various providers around, such as the DIaaS, to enable the research community to essentially develop the application once and not have to worry about reconfiguring everything if they move to different providers. That's that's kind of to avoid this so-called vendor lock-in is something that we're quite keen on supporting. Yeah.
Yes.
So I'm not sure I understand well the question from Timothy, because the cloud bursting is a service that takes as input a package, an application package. But Timothy is happy with the answer, so it should be fine. And is it open to all to contribute? Yeah, it's open to all having ideas to bring a software library and to have it available as an installable application package, and then decide on how to share this on the platform.
I wanted to make a quick or ask a question myself, because I come from an academic research background, and the hurdle to go from my own workflows to putting those workflows onto the cloud is quite significant, especially for scientists that aren't necessarily particularly tech savvy. So I was wondering, the Leap launchpads service, which is coming, right? Is that a very nice? Is that a framework that would enable the onboarding of less tech savvy scientists to make use of the services in NextGEOSS?
We hope so, yeah, because in this collaborative platform, you can step in as a user of something already prepared before. So you have different ranges of knowledge or skills on the platform. So we have software developers who might be researchers or working for standardization related activities. They will deliver something reusable by others under an open license typically. So as a scientist, you could come in and you know that you should use the Snap toolkit with your Sentinel-1 data, and you could simply find the application package that will do a graph that you are interested in, that will process the Sentinel-1 data in a way you are interested in. And so you will engage with NextGEOSS not as a developer, but right away from scratch at the launchpad level. You will select an application package. You will need to understand how to get cloud resources provisioned for you. So NextGEOSS is supposed to explain this, and then you run this application on the cloud to get your products processed.
Fantastic. And that provisioning part is where EGI essentially assists the researchers as well.
So
it's here we should mention EGI is a partner in NextGEOSS because of the position in Europe for EGI, supporting science and researchers. And so it's a way to provide grants when you need cloud resources for publication, for research work. It is quite natural and automatic to go through to EGI as a provider. Then if you are more into commercial, it's still possible, but you may already have an agreement with Amazon Cloud Services or with a provider of the DIaaS, and you would like to use that agreement that you have in place with your organization. And so in that case, you will be supported as well.
Right. So you're quite free to use any cloud basically to deploy your application that you develop on the NextGEOSS platform. So it gives great flexibility, but I want also to highlight actually this transparency because we are using open source and open APIs, basically most of the time at least. We also facilitate this transparency. I just came from the Polar Data Forum, and this issue of transparency is extremely important in the polar regions. And not only there, of course, but there are many applications in society where transparency is key. And this is being brought up in Geo also, by the way. So I believe that transparency all the way is something we can offer on the NextGEOSS platform, right, Epping?
Exactly, very important point, because we hope that these mechanisms we have developed and we offer in NextGEOSS will support reproducibility. So it will support more people in the world to take a result and go back on the process and make either a verification or make a slight modification in some parameters and compare. And so this capacity to support reproducible science is very important, also for educational purposes. And so we put a lot of hopes into this to develop further in the next year.
Fantastic. So, Richard, we are very happy that you found this webinar useful and eye-opening. I think based on the feedback on the polls, there might be room for more webinars covering cloud APIs and cloud technology in general. It looks like this is something we can go deeper into certain bits and pieces of it. If you agree on this, give me a yes or no in the chat box as we are closing. We are over the hour already, so maybe many of you have left. Marie-Françoise, absolutely. We are very happy to have OGC, so the Open Geospatial Consortium. They are working on standards, and they are strong believers, obviously, in using standards, and standards is indeed one of the tools we are using to make data interoperable along with the APIs. Okay, any final words, Hervé and Björn?
You have a yes already.
Yes, we have a yes. Fantastic. Yeah.
No, thank you, Bente, for organizing this. It was quite enjoyable, and looking forward to the next one.
Yes, the next
thank you
one.
for hosting us.
Yeah. So I will do a commercial for the next webinar, the NextGEOSS webinar, which will already be on Friday, the 6th of December in the afternoon. We are negotiating with our American speakers on exact time. So what you can do is to go to NextGEOSS.eu and sign up for the webinar series. So you will get your invitation directly in your email box. We will talk about data management principles. We have data management principles in GEO, so the GEOSS data management principles, which were among the major achievements for the GEO through the Group of Earth Observation community. Now, you have also heard of the FAIR principles. So we will talk about these two principles and do some comparison and give a deep dive together with experts, both on developing the principles, and we also have a user from Meteo France who can tell how useful they are. So with that, I say goodbye for now. Follow us on Twitter, NextGEOSS, and also sign up for the webinars on nextgeoss.eu. Thank you for now. Bye-bye.
Thank you. Goodbye.